Okay, good evening, ladies and gentlemen, and welcome to this live session on Lean Six Sigma, where we go deeper into the concepts and uh, you know make our understandings a little deeper, a little what do you say, and we become a little expert, practical, etc. Okay, so before we begin, let's welcome the new members of the community. Okay, so there could be a lot of people joining today first time. So the people who are joining this live session first time, just type me in the chat box. First, we'll welcome them, and then we'll start the session. Okay. So just type me in the chat box if you are very new in the you're attending the session first time. Uh, yeah, Monday might basically because it's a busy day, so people turnout is comparatively low. Okay. And we are all what do you say, putting this into this. Okay, yeah, Ravindraji, thank you very much for your Guru Purnima wishes. Thank you very much. And you all are gurus basically, in your own field. So today, I'm covering Lean Six Sigma, but you are also Guru. So Guru Purnima is for everybody. That Guru Tattva which is there inside each and every of us. That has to be cherished. That has to be brought down. Super. Okay, so it's your first time. Fantastic. So everybody just type welcome, new members in the community. Welcome, welcome, welcome. We'll give the yeah. Welcome all the new members. So let me also type the welcome and then we'll start our session. Okay. Super. So today's topic is a very interesting topic, which is about Sigma. Okay. Today we are talking about Sigma. Okay, fantastic. So Maheshji, welcome to this community. Welcome to this live session. So we connect live on every Saturday and Monday. Okay, and we'll continue this. Chalo. So let me just share my. This is very interesting topic today, which I'm going to cover. Okay, super. So here is my whiteboard, which I am sharing with you guys. Okay. This. Uh, No, that is the next session. Okay. Maheshji, that is the next session. And whatever we are going to cover there is already covered in your package. Okay. So that is for the other people. All right. Yeah. That's a separate session. Not for the paid members. Okay. Chalo. Okay. Now the people who are there in the yellow belt wala community, now you can just leave that community because that community is just a temporary community built for yellow belt session. Okay, you can just build that. You can just come out of that. That will be better. Black belt will be coming in this coming August first week. Okay, we'll cover black belt. Hackathon will be there. All right. Super. Chalo. So आज का topic we are talking about is today's topic is all about what is the topic, by the way? Calculating sigma of your process. Understand this? So we are going to learn how do we calculate sigma of our process. By the way, what is sigma? Type in the chat box. What is your understanding of sigma? What does it mean? Which is basically denoted by this. A knockdown 6. So what is this sigma all about? Variation, measure of variation, standard deviation. Very good, very good. Variation, measure of variation, standard deviation. Perfect. Super, super. Yes, correct. Now, this sigma basically what? So why this sigma is important for us to measure? Why this? Let's build the why first. Why? If why is clear, then what will become even more clear? Yes, why it is so important according to you? Just in one or two words, what is the importance of sigma? Why we should measure sigma? indicates accuracy to measure defects. Major defects. Okay. Decision making. Okay. Decision making to check process variation stability. Improvement in quality process. Okay. Very good. Super. Very nice. Very nice. Very nice. Now, do we measure? So, which data we should consider to measure sigma? Let me go deeper into this. You are absolutely right. My first question was, what is sigma? So you said this is variation. It's a measure of variation. Absolutely right. All right. Then why are we measuring sigma? Just to check the variation, the process. It's not basically stability. It's basically capability. Of course, stability also can be checked. But basically whether the process is capable or not. Now, my next question is, which data should we collect to calculate sigma? Because in our processes, there are so many data points we have, correct? Which data should we collect? Now, understand my question first, because this question will open up your, your mind about this. Which data we should collect to calculate sigma? Think about it and give me the answer. Which data? Continuous data, okay. Yeah, that's a type of data. You're right. Discrete data, continuous. There are types of data. Okay. There are types of data. Which data basically ratio? Okay, no. Which data basically do we collect to calculate the sigma? Now, just understand this. There is something called, so before we touch upon this topic called sigma, okay, we want to remove defect. Yes, now this is very close. Okay, output data, very good, very good. And where we want to remove the defect. Now, there is a terminology which is called as critical to quality, which is called as CTQ. Let me give you a simple example. All right. Now,
possible to class
unmuted. All right. Okay. Now, understand this. What is CTQ? Try to understand this. Critical to quality. CTQ meaning critical to quality. Now, in your product or service, which is more critical as a quality aspect for the customer? Example, when we go to a pizza delivery or pizza shop, let's say their Domino Pizza or Pizza Hut or whatever it is. Now, what are the critical aspects you are looking for there? You are looking for the test. So here, let me write some of them. Okay. So test is one of them. What else? Maybe hygiene could be one of them. Or delivery time could be one of them. These are the critical parameters, critical aspects which are important for the customers. Are you clear with this? Taste, hygiene, delivery time. There could be many more, but this is where, when I'm talking about a pizza shop, these are the critical to quality parameters which can be measured. Everybody with me till on this point, just give me yes in the chat box. Before talking about sigma, let's understand which data we should collect to calculate sigma. Clear है? यहां तक समझ में आ गया everybody? Yes, very good, super. Anybody who has not understood this, let me know. Now, if you have understood this, for your process, okay, whichever product or service you have, okay, give me one critical to quality attribute. One, or you can give me two, but at least give me one, which is important for the customer and you are measuring it. Type in the chat box. Very, very important. It could be delivery time. For a BPO, it could be the, the average call handling time. AHT, we call it as AHT, correct? For pharmaceutical companies, it can be assay, correct? Time to response, very good, super. Type 1, critical to quality parameter, which is important for the customer. DOT क्या है रविंद्र जी, थोड़ा सा हमें समझाइए. Okay, pH and assay. Okay, delivery on time. Okay, very good, very good. Delivery on time, very nice. So you are measuring the delivery time basically, right? Purity, super, very nice. Just one. Everybody please type 1 so that you can connect with your own process. And this is what we do in the live session, okay? Particle size of the material, very nice. Reply of the mail to the customer in 24 hours, okay? Now understand this. These are the critical to quality, okay? AQL pass rate, fantastic. Now, you must be measuring that in your process and recording that in your process. Just type yes if you are. Just type yes. If you are measuring all these critical to quality attributes. Yes? Are you getting my point? Yes, very good. So, isko hame measure karna hai to find out sigma. Are you clear? Which data we should collect to find out sigma? Clear? Because a lot of people get confused. Okay, sigma is clear, but which data? The answer is critical to quality data we have to collect to calculate our sigma. Okay? Yes, so whichever is important for the customer, absolutely you need to collect that data. Okay, no? Yes, are you clear? Very good. Now, for example, now let's say Yogesh is saying temperature and pressure. Now, these can be internal data points as well. इसका भी आप कर सकते हो, ऐसा नहीं इसका नहीं कर सकते, इसका भी सिग्मा निकाल सकते हैं. टेम्परेचर प्रेशर का भी सिग्मा निकाल सकते, स्पीड का सिग्मा निकाल सकते, व्हाटएवर. ओके, इंटरनल भी आपके कुछ पैरामीटर्स हो सकते हैं व्हिच इज क्रिटिकल टू बिजनेस पैरामीटर्स. दोस डेटा पॉइंट्स आल्सो यू कैन कैलकुलेट, बट मेजरली वी फोकस ऑन critical to quality attributes like this. Okay, now when we collect the data, let's do one small exercise here. Okay, now we have understood which data we should collect and why we should collect sigma data. Okay, patient wait time. Okay, now let's do one simple exercise, and now we'll calculate sigma, okay, which is standard deviation manually. We'll calculate it manually. Okay, yeah, can I have your heights in centimeter in the chat? Okay, सबके heights डाल दीजिए आपके अपने अपने. Okay, 170, 180, 150, whatever is your height. Type in chat box. Okay, उसमें से मैं कुछ heights ले लूंगा, and then we'll calculate our we'll take a standard deviation from there. Okay, so I'm just randomly picking up the heights. So 162 is there. I am observing one. Let's say 65 is there. I saw 170 somewhere here. Yes, then I saw 172 also. Okay, 156. जितना ज्यादा लेंगे उतना ये हो जाएगा. Okay, and then maybe 175. Okay, let's take these many data points. Okay, so we have taken these many data points. Okay, 5 data points ले लेंगे. So randomly we have chosen. Okay, and imagine there is a recruitment for the army going on where height is the criteria. Okay, so this is where we're collecting. So the critical to quality for this particular purpose is the height. So CTQ is height in this case. So we have collected the height data. Now what we'll do? So the first step is to collect the data. Always. Step number 1 is to collect the data. Okay. Now the step number 2, everybody can just pull out your calculator because we are going to manually calculate it. Okay. आपका मोबाइल कैलकुलेटर ओपन करिए या फिर लैपटॉप में या फिर whichever simple calculator if you have, just open it. Can you just calculate the average of this? Just take the average. So here I will write data. Okay, first you collect the data. Now you are calculating the average of this. Can you just calculate average? 168.8, is it? 168.8. 168.8, correct? Just for simplicity, can we say 169 just for our simple calculation? Okay, we'll round it off to 169. Okay, just for our simple calculation. Everybody just take average as 169. को डेसिमल को रिमूव करने के लिए, just for your simplicity. ठीक है? Now, everybody, so we have collected the data, we have taken the average. Now, the step number 3 is from the average data point, let's calculate the deviation. What is deviation? The distance from the mean, which is average. Average meaning the mean. Okay. Usko hi mean कहते हैं. So what is the distance from the mean? For example, so 162 minus 169. So that becomes minus 7. Okay. 165 minus 169 becomes minus 4. Then 170 minus 169 becomes 1. 172 minus 169 becomes 3. And 175 minus 169 becomes 6. Everybody with me? Yes, just give me yes in the chat box. Understood? I've just calculated the deviation. Yeah. Now, can you just calculate the average of the deviation? Let's calculate the average of the deviation. What is the average of the deviation right now? Average ke liye you have to add average of the deviation. Okay. You have to add all of them divided by 5 because the 5 is the total number of data points. So then what is the average of the deviation? So minus 7 minus 4 becomes minus 11, 10 and then 9. Okay. So it is kind of minus 1 divided by 5. Minus 1 divided by 5 कितना होता है? Minus 0.2 है ना? Right? Everybody? And you know what? This minus 0.5 has come because of this rounding off effect. Otherwise, it would have come 0. Are you understanding this? Because of this rounding off, this 168.8 को हम लोगों ने 0.2 से round off किया, right? Because that's why this average. Otherwise, this would come 0. Are you clear? Now, why it is coming 0? Does it mean it is not having any deviation from the mean? Does it mean it does not have any deviation? Yes, it does have the deviation, right? Because 162 we have, 175 we have. So always there is a deviation here. But why the deviation is not coming here? Because yes, because of the minus and plus are getting clashed. And that's the reason this deviation is coming very close to 0. This minus 0.2 also would not have come if you would have taken 168.8 precisely. This would be 0. Why this was 0? Because minus and plus are clashing with here. So to avoid this, what statisticians have done, they have taken the squared value of this. What is squared value? Squared value is always a positive value. Understand this. Minus 7 square is 49, which is not minus 49. Minus 4 square is 16 and not minus 16. Okay, because we get always positive value, they have taken the square of the deviation. Can you just do the squaring of the deviation? So the fourth step is square the deviation. Okay. So what is the square of 7 ka minus 7 ka square is 49. Okay. 4 ka square is 16. Then 1 ka square is 1. 3 square is 9 and 6 square is 36. Now, because we have taken the squares, now you can take the average of the square. Can I just do the averaging of this? 49 plus 16 plus 1 plus 9 plus 36 divided by 5. Now you take the average. So the average of squared deviation. Okay. What is the average coming? 22.2. Yeah, right. 22.2. And this is called as average of squared deviation. It's called as variance. Make a note of this. This is called as variance, which is also denoted by sigma square. Variance or sigma square. This is average of squared deviation. Clear? Now, because we have taken the square of the values, let's take the square root of this value. Okay. So let's take the square root of 22.2. So step number 6 is take square root of variance, which is sigma square का square root लेना है, which is equal to 22 का square root लेना है. 22.2 का is going to be 4.71. Okay, let's take 4.7 for this matter. Now, this is called as standard deviation, which is denoted by sigma. Everybody clear with this? Just give me yes in the chat box. So 4.7 is the standard deviation. Have you understood the 6 steps? Everybody, just take a screenshot of this very simple thing. First, you collect the data, take average, calculate the deviation. Then you can square the values of the deviation. Take the average of the squared value. And then you take the square root because we have taken the square of that, right? And the final value is called standard deviation, sigma, 4.7. Everybody clear? Just give me yes in the chat box. All the 6 steps are clear, the step by step. I've decoded how the sigma is calculated. Clear hai ye? Now you have never have to do this manually. Never, ever, ever. But you should, as a Six Sigma practitioner, you should understand what is sigma in great details. That's why I have just broken down this each and every step for you. Now, what is the so our data is in centimeter, but does standard deviation have any kind of unit of measurement? Can it have any unit of measurement, standard deviation? Everybody? Yes, no? What do you think? Will it have any kind of unit of measurement? Just a number, okay, as per the data, same as the data of measurement, okay, no unit. All right. Now, so standard deviation. Now this, our data is in, what is the unit of measurement of our data here? We have calculated our heights in, what is the unit of measurement here? Centimeter, fantastic, cm, correct? So the standard deviation also will be in cm. Okay, and standard deviation has the unit of measurement and the same as of the data set. If data set is in meter, standard deviation will be in meter. The data set is in kilometer, standard deviation will be in kilometer. Are you clear with this? Just type yes in the chat box. Clear hai? So standard deviation has a unit of measurement which is of the same of the data set. Clear? Now, how do you read this? 4.7 का क्या मतलब है? What is the meaning of 4.7 centimeter? The simple meaning is from the mean, from the average, from that reference value, 168.8 actually, okay? All the data points are on an average 4.7 centimeters away. Are you understanding this? From the mean value, all the data points are 4.7 centimeters away from that reference value, which is the mean value, on an average. So in a simple layman's language, it is average distance from that mean value. Average distance from the mean value. Are you clear with this reference? Just give me yes in chat box. Are you clear with this? सबको समझ में आ गया है? Just give me yes. Let me share with you हाँ नहीं, वही स्क्रीन है, वही स्क्रीन. That is the same screen. Average distance from the mean. Okay. ठीक है. Now, let me just open one reference presentation for you. Just for your reference, okay? Now, what would happen if, before I open that presentation, let me ask this question. Let me do some modification here. What if instead of 162, okay, now listen to me very carefully. Yeah? Let's say, तो यहाँ पे इस data set का standard deviation is 4.7, okay? Imagine instead of this, we have somebody of the height of 150, the shortest person of the group, let's say is 150, and somebody having height 185. So what I've done, I've stretched the distribution of the data. Okay. What will happen to the standard deviation? Will it increase or will it decrease? Type I for increase, D for decrease. So we have the shortest person at 150 and the tallest person at 185 centimeters. Will it increase or decrease? Everybody. I for increase, D for decrease. Decrease or increase? Increase, right? Increase. Because the distribution has more spread. You remember what is standard deviation? It is a unit of measurement of variation. More variation, more will be the standard deviation, which is sigma. Lesser the variation, lesser will be the standard deviation sigma. Okay. So instead, let's say somebody is 160 centimeter. Okay. And the tallest person of the group is, let's say, 173. 170 is the tallest and the shortest is 164, let's say, for example. 164 is the shortest and 173 is the tallest. Now tell me what will happen to standard deviation. Will it increase or will it decrease? D for decrease. Are you clear with this? As the data set comes closer, the spread is coming closer, the variation is coming closer, the standard deviation is reducing. Okay. Now let me share with you this diagram, which will give you some clarity, which is already there in your green belt curriculum. Look at this. So the first diagram, just have a look at the standard deviation. Okay. First diagram, n is equal to number of data points, which is 23. Okay. X bar is the central value, which is the mean value, which is 5. And standard deviation is 175. They have calculated. S is for standard deviation. Okay. In the second, so this is first one. In the second one, now the variation is reduced. Understand this. Okay. The same number of data points, but they are very closely bounded. All right. The mean is at the center, which is the same at 5. But look at the standard deviation. From 1.75, it has reduced to 1.41. Are you understanding the indication? Now look at the third diagram here. It's the same number of data points, but more and more data points are around 5 only. So average remains the same, but the standard deviation has dropped down to 0.85. So as we come closer at the data set, the standard deviation or sigma is reduced. Are you clear with this? Just type yes in the chat box. ये समझ में आ गया? Everybody is clear with the concept. More the variation, more the standard deviation. Lesser the variation, lesser the standard deviation. Clear hai? And through Six Sigma processes, the DMAC processes, our job is to reduce the standard deviation, reduce the variation. Are you clear with this? Just give me yes in the chat box. ये समझ में आया तो आपको 50% sigma concept समझ में आया. If you have understood this, very simple. Any doubt, please let me know. Okay. Now, so let me just make this standard deviation formula just for your reference. So how do you write the sigma formula? So sigma formula is, you can write like this, summation of xi minus x bar raised to square divided by n. Okay, where xi meaning individual values. Make a note of this. Individual values. X bar is the average or the mean. Average, which is also called as mean. N is equal to number of data points. Number of data points. All right. This is a formula for standard deviation. Are you clear with this? Summation of xi minus x bar, which is nothing but, if you remember, deviation we have calculated. So xi is individual value, x bar is the mean. So deviation. So सबका deviation का summation लेना है, बाद में उसको square करना है, उसका average लेना है, उसका square root करना है. That's it. Just take this formula. Again, we are not going to use it manually because it is not possible, because we have huge set of data sets. Okay, software will do it, calculate it for us. Clear, everybody? Sigma is clear? Just give me yes in the chat box. Is sigma clear to you? Just give me yes. This is very important. Okay. Very nice. Super, super. Any doubt? The live session's main objective is to clarify your doubt and deepening your understanding of this topic. Okay. So I'm doing very, very basic fundamental. What do you say? Fundamentals are being clarified today. All right. Now, why is standard deviation important here? Why do we calculate a sigma for that critical to quality attributes? Because of this. Okay. Now, for every critical to quality attributes, there are some customer requirements. Okay. For example, if you remember pizza delivery, the same example I'll give, there is a customer requirement of 30 minutes, which is called as upper specification limit. If you deliver after upper specification limit, that is called as rejection or defect. All right. Yes. Like, let's say, for example, test also. Maybe you can have 9 out of 10 rating for the test. So this is the delivery time. Delivery time. Let's say test. There could be, upper specification limit could be 9 out of 10. At least you should score on the scale of 1 to 10. All right. So anything. So this is US, this is LSL, I would say. This is lower specification, not upper specification. Upper would be definitely 10. So you must test. Your each and every pizza must test 9 out of 10. So these are called as specification limit. Okay. For example, the pizza, let's say another maybe temperature. Okay. So temperature, let's say lower specification limit could be around 40 degree. Upper specification limit could be, I'm just giving you very random examples, okay? Maybe around 60 degree. So you have to serve the pizza between 40 degree and 60 degree. Let's say, if I draw this over here, maybe my target is this, which is 50 degrees my target. My lower specification is 40 degree. This is called an LSL, lower specification limit. And my upper specification limit is, let's say, 60 degrees. Imagine this, okay? Now, if I have huge variation in my serving temperature process, if I collect the data and I find the distribution like this, so all the data beyond the specification limit would be rejected. It would be a defect. Correct? So the objective of this entire DMAC framework is to reduce this variation, bring the process in the center so that no data or very less amount of data will go beyond specification limit, which will be rejected. Are you clear the fundamentals? So we are measuring sigma because we want to reduce sigma. We want to reduce the variation. Clear this fundamental? So for everything, we'll put specification limit and we'll make sure the process remains within the specification limit. Are you clear with this concept? Just type yes in the chat. Specification concept is clear? Just give me yes. So every CTQ will have limits, specification limit set. Correct? Whatever CTQ, critical to quality attributes you have given me just a while ago. Okay, now for that CTQ attribute, can you tell me the specification limits in the chat? Take one CTQ, let's say, for example, assay, in the pharmaceutical assay. Okay, so it could be what, 95 to 105. I'm just giving you example, okay? Or 99 to 101. All right, so this would be, and the target would be 100. So there'll be a specification. Can you just give this specification limit? For a tea vendor, it could be 70 degree to 90 degree. So you have to serve the cup of tea within 70 to 90 degree. That will be specification limit. Yeah, assay 100% minus 5%. Very good. So 95 becomes the lower specification and 105 becomes the upper specification limit. 100 being the target. Clear? Yeah, everybody, can you just give your specification limits in the chat? Very, very important now. Because once we are understanding sigma, now we are calculating what is our process sigma, and another topic I'm going to cover now. Fabric width 55 inches plus minus 1 inch. Very good. Super. So 55 is the target, plus and minus 1 inch is the, so 54 and 56 is the upper and lower specification. Cricket ball diameter USL is 77.26 and 7.11 is a lower specification. Fantastic. Very good. Very good. Super. Anybody, please put your specification limit. Let's connect with your own process. That will be great. Just one specification limit for the critical. So you have to collect the data and check the variation right now. And you have to reduce the variation. Okay, pH ka hai, which is LSL 5.1 and USL 5.3. Fantastic. Okay, so everybody's clear about it. Diameter of the pipe 2.0 plus and minus 0.05 centimeter. Fantastic. Amazing. So everybody's clear with this, I believe. Okay. Now coming to the next part. Okay. Let me talk about standard deviation is clear. Process, the specification limits are clear. Let's come to something called process capability. Okay, now this is very interesting. Process capability. What is process capability? Ability of the process to fit in the specification limits. Ability of the process to fit in the specification limit is called process capability. Okay, ability of the process to fit in the process in the specification limit. That is process. Or see, specification limits are customer requirements. So process's ability to fulfill the requirement of the customer is process capability, which is shown by this Z score or the Z bench. Okay, in our Minitab software, it is also called as Z bench value. Bench meaning the benchmark. Okay, let's collect it. Let's call it as Z for our simplicity. Okay, and what is the formula for this? Let's write down the formula. Upper specification limit minus X bar divided by standard deviation. Write down the formula. Upper specification limit minus X bar divided by standard deviation. Okay. Now, imagine, let's put some numbers here. Imagine there is a pizza delivery, the pizza store. Now they have let's say 50 degree as the target, which is, lower specification, target, and upper specification. Okay. So they have 40 degree as the lower specification and 60 degree at upper specification. So while delivering the pizza to the customer, that company has to ensure the temperature of the pizza should be between 40 to 60 degree centigrade. This is the specification set. Okay. If it is less than 40 degree, it is too cold. If it is greater than 60, it is too hot. All right. And both are rejected. Let's take a very simple example. Now, we collect some data. Now, while collecting, so everybody's clear about what data to be collected, right? Whatever is the critical to quality for us, that data we have to collect. And how many data points we have to collect? Minimum 30 data points. Everybody just type 3030 in the chat box. Minimum 30 data points you should collect. Why minimum 30 data points? Because statistically, the moment you collect at least 30 data points, the normal distributions to start to take the shape of the distribution. Take the normal distribution shape. Okay, minimum 30 data points. All right. Now, how they have arrived at this 30? आप भी इसको कर सकते हो, आप सॉफ्टवेयर में भी आप इसको कर सकते हो. Okay, हम लोग करेंगे उसको थोड़ी देर के बाद, right? So minimum 30 data points to collect, and let's imagine I calculated the average. Okay, now I am imagining certain things here. My average of, let's say I collect 30 data points of the pizza. That means I've taken 30 pizzas. I've checked the temperature of each and every pizza. So imagine my pizza average temperature is 50 only. And standard deviation is, let's say, 5 degrees centigrade is my standard deviation. Are you clear? Now, let's quickly. So here, and what is my USL? USL is 60 degrees centigrade. So can you calculate my Z value here? My USL is 60 degree, which we have already seen. Upper specification is 60 degree. My standard deviation is 5, and my X bar is 50 degrees. Can you calculate the Z value here? So let's put the Z value here. USL is 60 minus 50, which is X bar, divided by 5. Correct? So 10 divided by 5 equals 2. Everybody got the value 2? Very simple. Now, when this process, okay, so let me draw a simple, a graph here so that it will. So this process is having sigma 5, standard deviation 5, and a Z value at 2. What does it mean? So when the Z value becomes 2, this is called as 2 sigma process. Or you can write 2 sigma like this. How many of you got it? Just type yes in the chat box. The moment the Z value becomes 2, we can call it as my current process is 2 sigma process. Are you clear with this? Just give me yes in the chat box. Just give me yes in the chat box. मैं आपको पूरे 6 sigma का निचोड़ आज के सेशन में दे रहा हूं. Just give me yes. If you have not understood, ask me the question. Okay. It will become more clearer. I've just imagined, I've just assumed certain values. Because my Z score is 2. Just stay here. When my Z score is 2, that process is called as a 2 sigma process. Itna tak aap yaad rakhna hai. Just stay till that point. Okay. I'll explain. Why we have taken, randomly I have taken 5. Mukesh ji, I'm randomly taken 5. See, the same process, the 6-step process we have to take. Take the 30 data points, take the average, okay, take the deviation from each and every data point, square them up, all right? Then take the square root of it. So all the 6 steps we have calculated, and let's say sigma comes to 5. Okay. I'll come to that. Sachin ji, I'll come to that. What is the Z का और CPK का क्या relation है? I'll come to that. Okay. यहाँ तक everybody with me. When the Z score comes to 2, it is a 2 sigma process. Are you clear with this? Just give me yes in the chat box. Just give me yes. When the Z, in this formula, if you put this value, when the Z value comes to 2, it is a 2 sigma process. Clear? Now, 2 sigma is a poor process. Yes, we have to increase this sigma, we have to increase that value, Z value. Now, what we'll do, so we'll go deeper to understand the variation. We will do fishbone analysis, man, method, machine, material, measurement, and we'll reduce the variation of that. Yes, X bar is the average. Very good. X bar is the average, but target is 50. Right now, our average is also 50. Okay, that is one consideration I'm having. Correct? Okay. Now, understand this. So how do we reduce the variation? By using the DMAC framework, by using the fishbone analysis. We'll ask the question, why is there any man-related causes of the variation? Is there any machine-related causes? Is there any measurement-related causes? Is there any material related cause, right? So all this we'll find out. We'll find out the root causes. We'll take some action, find out solution, and we'll reduce the variation. The moment we'll reduce the variation, let me draw a process like this. This is the new process with having reduced variation. Now, when my process comes closer in the center, what will happen to sigma? Standard deviation will decrease or increase. We have just discussed this. What will happen to standard deviation? D for decrease, I for increase. Type in the chat box. Very good. It will decrease, correct? Always remind live lecture session link at what? प्रेम शंकर जी. Okay, प्रेम शंकर जी इसको मैं डिस्कस करता हूं. Okay. So, everybody here with me, just give me yes. The moment we reduce the variability, we what do you can say? Reduce the standard deviation. Now, imagine once we reduce the standard deviation, the sigma, let's say in the second way, after improvement, the sigma from 5 degrees centigrade has dropped down to 2 degrees centigrade. From 5 degrees centigrade dropped down to 2 degrees centigrade. Okay. All right. Now, can you calculate the Z value now? Put the same in the same process. Can you just calculate the Z value? 60 USL minus X bar remains 50 only. So 60 minus 50 becomes 10 divided by 2 becomes 5. Correct? Everybody with me? So इसमें सिर्फ denominator change हो गया from 5 degrees centigrade से 2 degrees centigrade. Clear? Now, so the denominator becomes 2 and my value becomes 5. So when my Z value becomes 5, 10 divided by 2 is equal to 5. That becomes 5 sigma process. Are you clear? How many of you are clear with this? Just give me yes in the chat box. When my Z value becomes 5, my sigma becomes 5 sigma process. My process becomes 5 sigma process. Okay? Clear? Now understand this. Okay. When my standard deviation was 2, okay. So imagine X bar is 50 and this is USL, right? So imagine this band, okay, this band. Just focus on this portion. Only half a portion. Just focus on half a portion, okay? Now, this is between 50 to 60 degree. Yahan tak everybody with me, huh? Just 50 to 60 degree. That means the total is 10 degrees centigrade between USL and X bar is 10 degrees centigrade. Yes or no, everybody? Between USL and X bar, it is 10 degrees. Yes, everybody with me? Just give me yes in the chat box. Yes, everybody with me? Just give me yes. Between USL and X bar is 10 degree, right? When my Z score was 2, okay. So when my Z score was 2, let's say, for example, when my standard deviation was 5 earlier, my sigma was 5. So I could fit only 2 standard deviations in this. This is 5 and this is 5. I repeat again, listen to me very carefully. Focus here, focus. Everybody, focus here. When my standard deviation was 5, between these 10 degrees, I could fit 2 times standard deviation. 5 and 5. Two standard deviations. 2 times. Are you clear with my statement? Between 60 and 50, I could fit 2 sigmas, 2 standard deviation, 2 times standard deviation. Just give me yes if you have understood this. When I could fit 2 times sigmas, that is my 2 sigma process. How many have you got a bulb on moment right now? When my sigma standard deviation is 5, I could fit 2, 5 and plus 5, right? So when I can fit 2 sigmas, so this is 1 sigma, 5 centigrade wala 1 sigma. This is 1 sigma and this is second sigma. Are you clear? When I can fit 2 times my standard deviation, that is my 2 sigma process. The same way, when my standard deviation is 2, I can fit 5 times 2 between this 10 degrees centigrade. Because I can fit 5 times standard deviation, that process is called phi sigma process. If you got it, just type yes in the chat box. Simple. How many number of sigmas you can fit between your mean and X bar? The same formula, same here. Are you clear with this? Just give me yes in the chat box. Okay. Clear, everybody? I'm not getting everybody's comments here. I'm only getting 2 to 3 comments. Just give me yes if you have understood this. If how many sigmas you can fit between mean and upper specification limit, that defines your sigma. Okay. Yes. Rajan, just listen to this very carefully. When my sigma was 5, when my standard deviation was 5, between 50 degree and 60 degree, and my sigma is 5 degree centigrade, right? So I could fit only 2 standard deviation, 5 and 5 each. Within this 10, I could fit 5 and 5 2 times, correct? Yes or no? When I could fit 2 times sigma, that process is called as 2 sigma process. Okay. Now I improved my process. My variation is reduced. My standard deviation reduced to 2. Now I can, in the same passage of 10 degree, now I can fit 5 times standard deviation because my standard deviation is reduced. Because my standard deviation is reduced, I can fit 5 standard deviations. When I can fit 5 standard deviations in upper specification and mean, that's where I call it as a phi sigma process. Clear? Eh? Yes, now you got it. Very good. Super. Now, understand this. So when I call 5 sigma, okay, 5 is representing this Z value, which is nothing but process capability. And sigma is representing the standard deviation. So it is a combination of the Z and standard deviation. So I always, to remember this, I always remember this like this. I call this Z for sigma, ZIGMA. There is no statistical term for this, but for our simplicity of remembering, okay, we call it as sigma combination. When I say sigma, this 5 number is the sigma number and standard deviation is sigma number. Standard deviation is sigma number. So our job in the project is to reduce the standard deviation and to improve the process capability and the Z value. Are you clear? So standard deviation, sigma has to go down and sigma has to improve. Are you clear with this? Just give me yes in the chat box. Clear hai? So sigma has to reduce. By reducing the variation, we reduce the sigma. As the sigma goes down, our sigma goes up. And this is the crux of Six Sigma. समझ में आ गया? कितने लोगों का bulb on moment हुआ है? Just type BO in the chat box. If you got any bulb on moment today, just type BO. Okay, yes, today I got the bulb on moment. Super. Amazing. 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 Very good. Very good. Super. So this is how we have understood what is standard deviation and what is process capability, which is Z value. Okay. So the question was, can it be done on the lower specification limit? Yes. It can be done in the lower specification limit as well, or upper, either of these two. Okay. Yeah, Sigma pronunciation is our internal way of remembering this. Okay. Sigma is not a statistical term. ये मैंने invent किया हुआ term है. आप इसको sigma sigma, it's a rhyming ना. Just like our hypothesis testing में rhyme किया ना, P low null go. Right? Similarly, we have created the rhyming like sigma, but sigma is not a statistical term. Okay. If you find a statistical term, you will never find it. This is just for our understanding. Sigma sigma combination. Clear hai? So when we call 6 sigma, that 6th number is that sigma number, and the standard deviation is the process variability. So one is process capability, other is process variability. Okay. Clear? Very good. So any question which is unanswered, please let me know. Yeah. One point which was discussed earlier was improved process capability. We have to target decreasing the sigma. Exactly. Exactly, Ramanuj. You hit the nail. Exactly. 100%. So we have to reduce the sigma value to improve the sigma value. Okay. That is the crux of Six Sigma. And how do we reduce it? By using our, the DMAIC formula, the DMAIC principles, DMAIC, define, measure, analyze, improve, and control. Through this process, we reduce the variation and we reduce the defects. That is a simple thing. Okay. Now, yeah, one question was, what is the, just for our understanding. Okay. Have you taken the screenshot of this? If you wish, just take a screenshot of this. Okay. Because CP-CPK का question था ना? What is the relationship of Z and CP-CPK? Okay. Okay. If you're taking a screenshot, just take it quickly. I'll just write a table here just for your reference. Okay. Super. Now, let me just quickly talk about CP-CPK का और Z का क्या relation है. So you can just draw this table. Now, for the people who are not aware of CP-CPK, we have covered this in various times. What is the relationship between? So when the Z value is 1, let's say, for example, when it is called 1 sigma process, the CPK value generally is 0.33. When the Z value is 2, the CPK value is 0.66, and so on and so forth. Okay. When it is 3, the CPK value is 1. When it is 4, then the CPK value is 1.33. When it is 5, then the CPK value is 1.66. When it is 6, the CPK value is 2. So when the Z becomes 6, that becomes a 6 sigma process where the CPK value is 2. So what is CP-CPK? We'll cover it in other day. It is also same indicator, and there is a relationship between Z and CP-CPK, and you can convert it. In our Minitab also, we get the, both these options. Do you want a Z value or do you want to CP-CPK value? Okay, both options are available in our Minitab. Are you clear with this? Just give me yes in the chat box. Any questions which are unanswered, please let me know in the chat. Yes. Super. Now, yeah, CP/CPK is process capability, basically potential process. CP is basically the potential. CP, second, sorry. CP का ये है, is a potential process capability. And CPK का फुल फॉर्म है प्रोसेस कैपेबिलिटी इंडेक्स. Index. Okay, just for your reference. All right. Yeah, which point CPCP के this point, हाँ इसको मैंने अभी कवर नहीं किया है. If you are asking about CPCPK, this point we will cover later. Okay, because this was a question, that's why I just covered. Just take this table for your reference. Okay, I will cover CPCP के लिए एक अलग सा मैं सेशन लूंगा, तब मैं आपको एक्सप्लेन करूंगा what is CPCP. Okay. Yeah. And another thing, if you're not getting the intimations about the live sessions, I think Prem Shankar just asked this question. Okay. See, in our LMS system, you have the community tab. Everybody knows this. Just give me yes in the chat box. There's a tab called community in our LMS system. Okay. So in the community tab, you will get the latest update of the upcoming live session. Okay. So even if you don't receive any WhatsApp message or email IDs, okay, then go to community tab of LMS and you will find the the Zoom sessions link in the community tab. Everybody clear with this? Just give me yes. So even if you don't receive email, sometimes it lands in the spam folder, sometimes lands in the promotion folder. Sometimes it happens. It depends on the server. Okay. So don't depend on that. Even WhatsApp also sometimes, now a lot of there are some rules change in the WhatsApp. Okay, you are not able to send in the bulk messages. There are a lot of restrictions are there. So in some case, if you're not able to receive the message on WhatsApp or in email, just go to community tab and see our timings are fixed. Monday 7:30, Saturday 7:30. Timings are fixed. Okay, go to community tab. Whenever time comes, open the LMS, go to community, click on the link, and you are there inside the session. Okay, clear everybody? Just give me yes in the chat box. Super clear with this? Very good. Just give me yes. Prem Shankar, are you there? If yes, just give me confirmation that you've understood this. LMS में आप जाके directly enter कर सकते हो without any message, any email. Don't depend on the email or message. Okay. Very good. Very good. Super. Thank you very much for joining in. We'll connect again with the next station, next topic. Meanwhile, anything, any doubt you have, all the new members especially, just save this number, by the way. Okay, save this number, 99305 wala number hai. All the new member especially attending the session first time. And the recording of this will be kept in the master class archive. Okay, master class archive. This is the folder you will find in the LMS system. And as you enter into LMS system, start your journey from course number 1, which is our green belt course. Okay. So these are the inputs, and you would have received the intimation how to access the Minitab, etc. Okay. Wherever you find any kind of doubt, challenge, just send a message on that WhatsApp number. Okay. Save this number as a mentor's WhatsApp number. Okay. If sigma value goes above 6, yeah, above 6 is always good, no? See, it can go to 7, 8, 9, 10 sigma, 11. There is no limit for that. It's always good. That means you are coming very close to the center. Okay. And your process is coming very lean and slim and trim. That's very good. 6 is not the ceiling. 6 is why the name was given by Motorola. Okay. Because they were around 2 to 3 sigma level and they wanted to achieve 6 sigma level. That's the reason they set a target. And because they name the drive as 6 sigma, we are following the name as 6 sigma. But 6 is not the ceiling. We can go beyond that as well. Of course, it is very difficult, by the way, to maintain that accuracy and precision for a very long time. Okay. In the short bursts of the time, you can reach 6 sigma levels. but to continue for a long term. Okay, that's where you have the short-term process capability and long-term process capability. Okay, that also is calculated. Okay. Six Sigma question, interview questions and answer. Go to Masterclass Archive, Ramanuji. Recently, I think 1 month back, we had taken a session on that. And below that, there is a downloadable document where interview questions are also given. Okay. So green belt, black belt, master black belt, all these levels, what are the interview questions generally are asked? There is a list given. You can refer that. You can download that. Okay. Six Sigma is the final stage. No, you can go beyond Six Sigma. You can go beyond 7 Sigma, 8 Sigma, 9 Sigma. But that's what I said. In a short span of time, you can. But for a longer duration of time, let's say it's like this. Now, see, you can hit centuries. You can hit a century. But hitting century in every match, let's say hitting Six Sigma value is, let's say, hitting a century. But hitting century in every match is very difficult. That's the same thing. So taking the Six Sigma level, reaching to Six Sigma level is what you can say possible, but remaining at that level is what is the challenge. Okay. Can you please share the links? So what you can do, Maheshji, is go to the masterclass archive. That's what I said. Okay. And scroll down. If it is open, let me share with you. Okay. Let me just see if I can directly show it to you. Okay. Yeah. So all the new members, let me share my screen for masterclass archive. When you, everybody's got the login ID password, right? Very well explained. Very good. Thank you very much. Okay. Now, if you have not got login ID password, have any doubt how to log in the system, please send a message and our team will support you in that. Okay. Now, once you log in, just check Masterclass Archive. There is one folder called Lean Six Sigma Live Masterclass Archive. There are 353 sessions recorded for you guys. Can you believe 353 sessions recorded? Okay. Now you don't have to worry about it. You just have to scroll down. Now every session, see, this many sessions are available for you. Okay. The last session, if you scroll down, the last session will be the latest session. Okay. Yes. So I was there. There are some other mentors also in between, but majority, 90% of the topics are taken because see, our consultants are always on the run. So generally I take these sessions. So I become the lead faculty as well. Okay. So here, Gauge R&R was taken on Saturday, 12th of July 2025. You can see here Gauge R&R practical. Before that, it was attribute agreement analysis. Yeah, so you will find out date-wise sessions taken. Clear, everybody? So this is the masterclass archive. I think I can share this preview link as well to you. You can check out. You can just click on the link and enter directly into masterclass archive. Okay. Introduction classes के लिए Maheshji, you would have received one message, WhatsApp message. In that WhatsApp message, there is an orientation video. You can just go through that orientation video. Yeah, that orientation video would be great help for you how to begin the journey. Okay, and it's very simple. Just start with the course number 1. All right, that's a simple what I would say. Okay, thank you very much, guys, for joining in. Keep learning, keep growing. This is Dinesh Patil signing off.